Hey, this is Mr. Beckstrom, and I'm going to do an example from section 1.4. This is 95, and says, given the following information about one trigonometric function, evaluate the other five functions. So they give us the cosecant of theta, which is equal to 13 over 12, and they want us to find the sine, cosine, tangent, secant, and cotangent. There's numerous ways to do this. We can do this with trig identities, like the Pythagorean identity, but the easiest way to do this, as far as I'm concerned, is just draw a triangle. Now, this information here tells us that we're in the first quadrant, and we should know that in the first quadrant, all of our trig functions are positive, so all 6 of our other functions should all be positive. So I'm going to make a little makeshift graph here. And what I'm going to do is I'm going to create just an arbitrary right triangle here in the first quadrant. Now, if we look at SOHCAHTOA, I'll write this out again. SOHCAHTOA and TOA. And this is just a little thing that helps us remember the definitions for the three main ones. And we also know that cosecant is 1 over sine, so it's kind of the inverse of the sine. So if the sine is opposite over hypotenuse, then I know the cosecant is hypotenuse over opposite, because we just flip these two things around for the cosecant. So in this case, it's hypotenuse over opposite. So here's the hypotenuse because it's across from the right angle. So this is 13. And the opposite side from this angle here, which is going to be our theta, is going to be 12, which makes this remaining side 5. Now I know this because this is a known triangle of 5, 12, 13, but I can also use the Pythagorean theorem to find this missing side, where you have 13 squared, which is 169, is equal to 144, should be better, equals, plus the final leg squared, so a squared is equal to 25, and finally a is equal to 5. So once I have my triangle, then I can really easily find the other 5 trig functions. So first I'm just going to write them out. So the sine of theta, the cosine, I am not very good with a mouse in this program, cosine of theta, the tangent of theta, the secant of theta, and the cotangent of theta. Remember, we already have the cosecant, which they gave us. And once again, remember, I know that these are all positive because we're in the first quadrant, where everything is positive. Why? Because all of my x's are positive, all of my y's are positive, so all of my x's divided by y's, or my y's divided by x's, are also positive. Alright, so the sine is opposite over hypotenuse, so that would just be 12 over 13. Cosine is adjacent over hypotenuse, so with this theta it would be 5 over 13 over 13. Tangent is opposite over adjacent, so 12 over 5. The secant is 1 over cosine, or since the cosine is adjacent over hypotenuse, the secant is hypotenuse over adjacent, so that's going to be 13 over 5. 13 over 5. And finally, the cotangent is 1 over tangent, and the tangent is opposite over adjacent, so the cotangent is adjacent over opposite. So it would be 5 over 12. So 5 over 12. And that is all of them. If you have any questions, let me know. I hope you have a great rest of your week. Thanks.